Hey, this is Mr. Janes. In this video, we'll talk about finding a linear equation given a point and a slope, maybe 2 points, or other information that isn't necessarily the slope and the y-intercept. So, speaking of slope and y-intercept, whenever I think of a line, I always think of slope-intercept form. Y equals mx plus b, where m is the slope and b is the y-intercept. Now, there's a whole bunch of ways to do this, and you might have a different way, but personally, whenever I'm trying to graph a line, I always try and find out what the slope and the y-intercept is first. That way it's a little easier to graph. So in all 6 of the problems we look at next, I'm going to try and find the slope and the y-intercept, and if I don't know them right off the bat, I'll try and figure out a way to determine them. Let's start with number 1. I need the equation of a line that passes through the point 1, 1 with a slope of 3. The good news is I already have a slope. That's 3. So let's write out the equation I have so far. Y equals, well, my slope is 3, so 3x plus, but I don't have a y-intercept, so leave that as b. How can I find out that y-intercept? Well, there's a few ways. The first way is to substitute in for y and x. I know I have a point for y and x right here, 1, 1, and I know that this point is on that line, meaning it's a solution to this equation. So let me substitute 1 in for x and 1 in for y. So 1 equals 3 times 1 plus b. Now I've got an equation I can solve to figure out what b, my y-intercept, is. 3 times 1 is 3. Let me subtract 3 from both sides and get that, let's see, negative 2 equals b. Okay, now I've got my y-intercept. So I can say that my equation is y equals 3x, again I had my slope right from the beginning, minus 2. I got my y-intercept from this operation I did. And that kind of makes sense, because if you think about it, if I had a graph like this, it passes through the point 1, 1. So 1 on the x-axis, 1 on the y-axis goes to that point. And it's got a slope of 3. Right, that means I can go over 1, up 3, 1, 2, 3 to get to another point, and I can go back 1, down 3, 1, 2, 3 to get to another point, and it looks like, by that logic, I would have a y-intercept of negative 2 right there, and that's exactly what I had. So either by doing it algebraically like I did, or by kind of starting at that point and working backwards on a graph, you can figure out that your equation should be y equals 3x minus 2. I think that you could probably try number 2 on your own. Pause the video here and try number 2. We'll start going over the answers in 3, 2. It's really important that you at least read the problem, give it a try, write down anything you can, any information you know, before pressing unpause and watching the answers. That means you chaif. 3, 2, 1, here are your answers. So here's my solution so far. Just like in the last problem, they gave me a point that my line goes through, so 5, 0, and a slope, negative 1/2. So I started by writing out the equation I knew so far. Y equals negative 1/2, that's the slope, times x plus b, because I don't know what the y-intercept is. But I do know that this line passes through the point 5, 0, and since it passes through that point, it's going to be a solution to my equation. So I just substituted in 0 for y and 5 for x, so I have 0 equals negative 1/2 times 5 plus b. Negative 1/2 times 5, I wrote that as a fraction, negative 5 over 2, but you might know that as a decimal. That's 2.5, again that's really half of 5. I added 5 halves to each side, again that's 2.5, and I got that b equals 5 over 2, again that's the same as 2.5. So now that I know the y-intercept and my slope, I know that the equation of this line is y equals negative 1/2 x plus 2.5, right? And again, that kind of makes sense graphically, because if I think about a graph, okay, we start at this point 5, 0, so that's 5 in the x-axis, 1, 2, 3, 4, 5, let's say I'm over here somewhere, and I've got a slope of negative 1/2. That means that my line's going to be going down in this direction, negative slope. So if I back up a little bit, it's reasonable to assume that it's going to go through somewhere around like 2.5 on the y-axis. That kind of makes sense. Number 3 is a little bit different. In number 3, they give me 2 points my line goes through. So at the very beginning, if I think about y equals mx plus b, or point slope, I don't have the slope and I don't have my y-intercept. What am I going to do? Well, I have 2 points. I can find the slope between 2 points. Let's go ahead and start by finding the slope. So slope. That's change in y over change in x. Change in y over change in x. Now you might have a formula for that. You might use y2 minus y1 over x2 minus x1, but I prefer looking at it this way. The difference between 2 and negative 2, I'm decreasing by 4, going down by 4. So that's my change in y. My change in x from 1 to 5 is I am increasing by 4, which means that my slope is negative 4 over 4, or simplifies to negative 1. Again, I can divide the top and the bottom by 4 and get negative 1 over 1, and negative 1 over 1 is the same as just 1. Now I know my slope. Now I know so far my equation is y equals negative 1x plus, still don't know my y-intercept, b. So at least I'm halfway there, right? I'm halfway there. Now, all I need to do is the same thing I did in problems 1 and 2. Choose one of these 2 points to substitute in for x and y and solve for b. Because I know that both of these points are on the line, I can use either of them. But I'm going to use the first one, 1, 2, because those numbers are a little bit smaller, there's no negatives, and the math will probably be a little bit easier. So let's go ahead and do that using 1, 2. 1 for x and 2 for y. I'm left with negative 1 times 1 to simplify, which is negative 1. I can add 1 to both sides, and I'm left with 3 equals b. So it looks like my y-intercept is 3. So when all said and done, I have an equation of y equals, let's see, my slope was negative 1. Oh, I can write negative x for that, can't I? Y equals negative x, because negative x is the same as negative 1x. Can always put a coefficient of 1 there. So y equals negative x, again from up here, plus 3 for my y-intercept right here. Again, it kind of makes sense graph-wise too, because if I plotted the points 1, 2, and 5, negative 2, my original 2 points, on a graph, and connected them with a line, you kind of see that, yeah, my y-intercept would have to be 3, and my slope would have to be down 1 over 1, down 1 over 1, right? Which is a slope of negative 1 over 1, or negative 1. That's what we had, right? So our answer kind of makes sense. Y equals negative x plus 3 by looking at it graphically. What about number 4? What information are we given? We're given the x-intercept is at 4 and the y-intercept is at negative 6. So what information do we have? Well, think about y equals mx plus b. We don't have the slope, so y equals mx, but they give us the y-intercept at negative 6. So y equals mx minus 6. So we need to find the slope this time. In problems 1 and 2, we need to find the y-intercept, but in this one we need that slope. How are we going to do that? Well, it'd be good if we were given 2 points, right? Well, we are. Remember, the x-intercept is where y equals 0. Think about it on a graph. Okay, the x-intercept, somewhere on this x-axis, is where y equals 0. We have moved up or down from the origin. So if y equals 0, y is 0, and x is 4. Same thing for the y-intercept. On the y-axis, say up here, x is actually 0. See, we haven't moved left or right from the origin. X is 0 right there. So x is 0, that's negative 6. And we can find the slope pretty easily between those 2 points, right? That's the change in the y's. So how far is it from 0 to negative 6? We've gone down by 6. And the change in the x's, how far is it from 4 to 0? Again, looks like we're going down, but this time by 4. A slope of negative 6 over negative 4, well, I can divide both the numerator and the denominator by 2 and get 3 over 2. And a negative divided by negative is a positive. So we have a slope of positive 3 over 2. Coming back to the original equation, we now have y equals 3 over 2x minus 6. There it is. Again, if you plotted those 2 points, an x-intercept at 4 and a y-intercept at 6, and drew your line, yeah, we do have that positive slope here with an intercept of negative 6. So y equals 3/2 x minus 6 makes sense. Let's finish up by looking at 5 and 6 together. In 5, they give me a point, negative 4, 2, and telling my line has to be parallel to y equals 2x plus 3. In 6, they give me the same point and telling me my line has to be perpendicular to y equals 2x plus 3. Wait a second. Have they given me a slope? Doesn't look like it. Have they given me a y-intercept? Doesn't look like it. And I don't have 2 points. How am I going to do this? Well, actually, they have given me a slope, whether you know it or not. Looking at this equation, y equals 2x plus 3, the slope of this line is 2. Now, remember that the slope of a parallel line will be the same as the slope of the original line. Think about that. Right? The slope of a parallel line will have the same slope, or the same steepness, as the original line. So the slope in this one is going to be 2. In number 6, I've got a perpendicular line. So again, my original slope is 2, but for perpendicular lines, I need to have that opposite reciprocal slope, also known as keep, flip, change. So my original slope, again, was 2. You can also call that 2 over 1. So opposite reciprocal means to flip the fraction over, 1/2, and change the sign from positive to negative. So my new line will have a slope of 1/2. At this point, these are just like problems 1 and 2, and you can probably do them on your own. We're given a point, negative 4, 2, and a slope. Or in number 6, we're given the same point, negative 4, 2, but a different slope. Go ahead, pause the video, and see if you can figure out the equation of those lines without me showing you. The full solutions will come up on the screen in 3, 2, Charlene, make sure you're pausing this. All right, let's take a look. In number 5, I start by writing out as much information as I know, y equals 2x plus b. Then, just like 1 and 2, to find my y-intercept, I can substitute in negative 4 for x and 2 for y. And then solving for b, 2 times negative 4 is negative 8. I can add 8 to both sides and obtain that b is 10. So my slope was 2, my y-intercept is 10, so my equation is y equals 2x plus 10. There it is. On the other hand, in number 6, I had the slope of negative 1/2, again because it was a perpendicular, opposite reciprocal slope. So I substituted in, same as before, negative 4 for x and 2 for y. Negative 1/2 times negative 4 is 2. Remember, half of 4 is 2, and negative times negative is a positive, so positive 2 plus b. I then subtracted 2 from both sides. 2 minus 2 is 0, so b equals 0, which leaves me with the equation y equals negative 1/2, remember that's the slope, x plus 0, or better yet, y equals negative 1/2 x. And I'll leave it there because 0 is not really going to change the value of my equation, so I don't even need to write it. Lastly, at the bottom, we have 3 things to think about. Now, what I'd like you to do is read through all 3 of these questions and write down a few sentences as responses to each one of them. They're not computation kinds of questions, they're more thinking and response kinds of questions. But I'll give you a few hints here, and then we will see what you've written down in class. Number 1, if the line y equals mx plus b has m greater than 0, means it has a positive slope, or greater than 0, positive, and b greater than 0, that means it has a positive y-intercept, okay, will the x-intercept be positive or negative? Why? Well, think about it. If you got a graph, something like this, and you have a positive y-intercept somewhere above the x-axis, and a positive slope, some sort of increasing line, will that have a positive or a negative x-intercept? Why? Jot down a few sentences. Number 2, is the point 3, 4 on the line y minus 2x plus 1 equals 0? Well, if you remember, we know that any point that's on the line will work as a solution to that equation. So maybe we should substitute in 3 and 4 and see if those actually equal 0. In number 3, we've got a line with 2 different slopes. One slope is negative 3 over 4, and another slope is 9 over negative 12. Shouldn't a line have one slope? Are those different numbers? Are they the same? Make sure you write a couple sentences as a response. Good luck, and I'll see you next class.